Okay, so these are some highlights from the second section in the textbook that we'll look at. Well, this week it's and for the course really. So we've got to think about, and I'm hoping that a lot of this is review from earlier courses. You should have seen domain range, but if you didn't, so all domain is it's all the possible inputs we put in a function. I'm going to do this from a table, an equation, and from a graph. I don't know if we can do the table right now, but definitely could. Um, so inputs are x's, outputs, all possible outputs are the range, and that's y. And some of these are limited, and so we got to talk about that. And then we're going to learn three different ways to express those, and then we're up to the first one. So we'll be able to knock off the first bit right here. So let's do it. So if remember back, I don't know, if you had back in Algebra 1 or maybe intermediate algebra in college, if you had to graph x is greater than 3, you drew a number line. I know I tell my folks just mark 0, mark the 3, because it's greater than, we'll have an open circle and we'll shade to the right because x has to be bigger than 3, larger than 3. And if this was greater than or equal to, I would have it filled in. We're going to keep that same kind of idea in these things when we're looking at two-dimensional graphs. Okay, here let's erase that. So what I'm seeing here is for domains, I'm seeing it goes from -3, and you see how it's filled in. The x, that point is filled in for -3. So that means -3 is included in the domain. And but at +3, there's an open circle. There's a dot there, not a filled in dot. It's open. So that means +3 is not included. And conversely, um, so let's talk about that. Let me not do the range yet. So if I want to write this as an inequality, I would say from -3 is less than or equal to x, which is less than +3. So I use the equal to because the filled in dot. I use just the less than because it's an open dot. And I'm going to write this as a compound inequality. No need to break out to two different ones. Put x in the middle. Put in the lower number, the upper number, and put the x in the middle. Now for the range, so that's the domain. For the range, I certainly see that 2 is included. 2 is not included here, but it is included over here. And then even though they didn't put a point on it on the graph, to me it looks like it touches the x-axis at -1. So that means it goes from 0 all the way up to 2. So I'm going to say for the range, I'm going to say 0 is less than or equal to, because it's included, y equals 0 is included, less than y, which is less than or equal to +2. In this case, it's both are less than or equal to. So y is in between those. Now, what about if they wanted me to do this in interval notation? You're going to see a lot of interval notation. So when you have a less than or equal to, well, first off, you're going to write down the two numbers. Then you've got to decide some more notation. And one of it, how do you give people information about the less than or equal to? Well, you use a square bracket, a hard bracket. And how do we do the less than? Just the plain less than without not including the +3. You do a soft bracket or a parenthesis. Okay, so that's how you communicate that to people. So thinking about this, 0 is included, 2 is included. What are you going to write? Knew I was going to tell you the answer. Inclusive of 0, comma, inclusive of 2. So both of those get hard brackets. Okay, then the last one, which can be useful, I mean, I'm not going to stress it in this course, is set building notation. And all set building notation is it takes the inequality and you add a little piece to it. So you say x such that, then you write the inequality. X is less than, so -3 is less than or equal to x, which is less than or equal to +3. And then you usually put French brackets, curly brackets around those. For the range, we'd write y such that 0 is less than or equal to y, which is less than or equal to 2. Okay. For this one, it's kind of lame. Set build is a little lame. You'll see when we get to some other ones here, set build is kind of nice. So that's domain and range from a graph and the three kinds of ways to express the result. Now, my open math, and maybe I already said this, my open math really is heavy on the interval notation, so you'll get good at that. It's hard. Sometimes people get, especially if it's two open intervals. If I were like, let's pretend this is an open interval here for this one. I would say for the domain, I would say doesn't include 2 and it doesn't include 8. So that looks like a point. So you kind of got to know what you're looking at. You got to think about it in context. Okay. So, of course, that wasn't the correct answer for this one because that was actually filled in. So I should have had I mean, do that question correctly for the domain. I should have had a hard bracket at 8. Okay. Anyway, so that's domain and range from a graph. Domain and range from an equation or from a function notation. So two things you got to pay attention to. I can't take the square root of a negative number, and I cannot divide by 0. Anything else goes. Well, there's another thing with logarithms, but we aren't there yet. Um, so what you do is if your equation has a radical in it, a square root in it, you've got to ask yourself, okay, I know I can't have the square root of a negative number, so that tells me, but I can have the square root of 0, can't I? So really what I'm going to do is I'm going to solve this inequality to figure out the domain. And of course, remember when we solve inequalities, we treat them like an equal sign, add 2 to both sides. And then I didn't divide by a negative, so I'm just going to replace the equal sign, with back to the less than or equal to. So x has to be greater than or equal to 2 is the domain of that function. It can be 2, so if x is 2, I get the square root of 0, and that's 0. And if it's bigger than 2, that's good. But if I were to try to substitute in x equals 0, say, that would be 0 minus 2. That's negative 2. I can't take the square root of negative 2 and stay in the real number system. Okay, so that's radicals. What about something like number 11? Well, I can't. That's a rational expression, a rational function, because there's a variable in the denominator. I can't divide by 0, so what I'm going to really do is I'm going to ask myself, where does x minus 6 equal 0? Well, x is when x equals 6, that happens, so x can't be 6. Okay, so that's that domain. Now, if we were to write these, so I've got an inequality. I've got kind of a set builder here. How do I write these in interval notation? Well, 2's the smallest, and it's included, and then infinity is the max, so it's going to be open. So that's how that will be expressed as a interval. This one's a little more complicated for interval. It can't be 6. It can be anything else. So what we'll do is we'll say we're going to go from negative infinity. Notice it's an open bracket to 6. It can't include 6, so I've got to make that open. I'm going to skip over 6, and then 6 to positive infinity. Okay, so that's how you write that one as interval notation. Notice this inequality notation, or even better, x such that x is not equal to 6. That's the set building notation, and that's much more concise than the interval. Okay, so we've done radicals, we've done rational expressions. How about something like number 15? Okay, so I see a radical, I see a rational expression. So let's worry about the radical first. I know that x plus 4 can't be negative. So where does x plus 4, where is that greater than or equal to 0? Well, that's when x is greater than or equal to negative 4. When does x minus 4 equal 0? Well, that happens equals a positive 4. So x can't be positive 4. X has to be bigger than, greater than or equal to negative 4. So interval notation, I'm going to go from negative 4. I messed this up. Just a minute here. I'm going to go from negative 4 because that's the bottom of it from here, and it's inclusive at negative 4 because it's equal to. Then I'm going to go up to positive 4. I'm going to skip over positive 4, and it's not included. I can't include 4 because that would make division by 0. I'll skip over 4, use the U to say or, and then from 4 to infinity. So that is that written as interval notation. I honestly think that's pretty concise. I don't think an inequality, because you get the two pieces, this says a lot, but not a lot of writing. Okay, so I'll warn you up front, if you're watching this video, You've got a question like this on the first exam, so make sure you know how to do them. Then the very last question in this type, and this honestly, I mean, if you remember this from Algebra 2 or from college algebra, great. People tend not to remember this, so that's why I wanted to show it to you. We'll spend some more time with quadratic equations um, in Chapter 3. Briefly, I mean, we don't spend a lot of time. There's one section. Here, let's do this. So in this case, now 0 divided by a number is 0. So we don't really care about the x minus 3. That's not an issue. It's the denominator. I can't have a number divided by 0. So what I'm going to try to do is I'm going to try to solve where does x squared plus 9x minus 22 equal 0. Now it's a quadratic equation. You could use a quadratic formula. I encourage you to try to get freshen up on your factoring. Because factoring is quick and easy, and if you can see it in a hurry, do it. It's otherwise, go use another tool. So x squared, what multiplies to give me x squared? X and x. And then what multiplies to give me negative 22? Well, I can get negative 1 times positive 22. I can write positive 1 times negative 22. I can write negative 2 times 11. I'm going to write 2 times negative 11. Those are the possibilities. Now, when I multiply, whatever I put in here and here, in order to get the middle term, I'm going to do the outside. So remember, what I'm doing is foiling. And remember, when you foil a binomial, two binomials, you do the outside product plus the inside product, add them together, and that's where you get the middle term. So whatever I put here is going to multiply by that x, and whatever I put here is going to multiply by that x. I'm going to put them together, and it's got to be a positive 9. So the only way I can add these two things together and get positive 9 is when x is negative 2 and x is 11. So I'm going to write negative 2 plus 11, and I'm done. I'm done with the foiling. And the last thing I got to do is remember to change the sign. So let's see. Will this let me pull it down? Oh, let's see. So what I got to say is x equals 2. When is x minus 2 equal to 0? Because it's supposed to be 0. And when is x equal to negative 11? Okay, so those are the two places that are not included in the domain. To write as a set builder note or as interval notation, let's go from negative infinity up till negative 11. And both of those are open because I can't include the negative 11. Of course, we can't include infinity. We can never reach that. We'll skip over negative 11, go up to 2. We'll skip over 2, go to infinity. And that's that domain as an interval notation. And that's it for finding them by looking at the equations, figuring out the domain. So now they were being asked, like you did back in the last section, to evaluate functions. But now we've got a piecewise defined function, which tells us we're supposed to use different pieces depending on the domain of the function. So for number 19, they're saying, hey, when x is less than 0, use that equation to come out to evaluate it. When x is greater than 0, we'll use that equation, or that part to graph it, okay? Um, so x is negative 1. Well, that's less than 0, so I'm going to drop negative 1 into that piece. Not even going to use the other piece. So what is that, negative 4? If x equals 0, I'm going to use that again. I'm going to use oh, I almost messed up, didn't I? Do you know you see how I messed up? I'm supposed to use this piece when x is equal to 0. So that would have been positive 6. And then for the rest of these, they're all greater than 0. I would use that second piece. Okay. This is a little more interesting. The next one's a little more, and I don't think you need me to see me actually calculate those, right? You just got to know what piece to use. Uh, these now we're using 2 as the cutoff. So for these two, we're going to use the x squared minus 2. But then because 2 is included in the second piece, for these two, I'm dropping them into that absolute value function. Right, you okay with the absolute value? Maybe we should talk about that. If x equals 2, say, so let's say I'm trying to find f of 2, I'm going to drop it into 4 plus the absolute value of 2 minus 5. 2 minus 5 is negative 3. The absolute value of negative 3 is 3. So 4 plus 3 equals 7. Okay, right? All right. And this now we have three pieces for 23. So less than 0. So we're going to drop negative 1 in here. Then we're supposed to use that constant function for between 0 and 3. So for both the 0 and the 2, we're going to use this piece, which it doesn't matter what x is. Y is always 3, right? So we'll have, let's do this. So this will be negative 5. F of negative 1 is negative 5, right? Because I drop in negative 1 here. For f of 0 and f of 2, they're all equal to 3, or both equal to 3. Double equals or. How about or? That way we don't have double equal qualities. And then for x equals 4, we're going to use this piece. Okay, it's that easy. Now we got to write formulas for a graph, and all of these are your toolkit functions for the most part. So you just got to decide what ones to use and where. And the best way to write a piecewise defined function is, let's set it up. So because I've got three pieces, I'm gonna have three imaginary lines. If you want to, you can put little dotted lines if you want. But between -6 and -1, and I'm gonna actually have both of those closed, I'm gonna use the equation y equals 2. And usually write the word on. So 2, when f of x is when x is between -6 and -1, y is going to be equal to 2 because it's a constant function. And then for the next piece, we use the next piece from -1 up to 2. And notice how they get an open circle at -1, because we can't have -1 included in both pieces, or else it would be a function, right? It would fail the vertical line test. So this one will be open because they gave it to me as an open, and then I'm going to close it at 2, and that equation is y equals -2. And then for the last domain, oops, I got to close this one, don't I? And then for the last piece, I see it's going from +2 up to 4, and +2 is open, and up to 4 is closed, and that equation is y equals -4. And then we'll just put a great big curly bracket, and we'll say f of x equals. And that's my piecewise defined function. Number 21, I see a constant function and I see x squared, quadratic. So, and there's only one breaking point at 0. So, let's see. So I'm going to say y equals 3. I can say on, I can say when. You're going to see it written a couple of different ways. I like the set build. I like the inequality. So, I mean the interval notation. So from -infinity up until 0 is the breaking point, and it's closed. See how the dot is filled in there? So I'm going to say that's closed. Whoops, what did I do wrong here? I should have left this as open. Because it can't reach infinity. And then I'm going to use x squared on 0 to infinity. And both of those are open because of the hole. Okay, so there's some toolkit functions. Last one, here, let's do this. Sometimes people have a hard time with linear functions. All these are well, this one's a constant function, right? But the other ones are just y equals mx plus b form of an equation of a line. So let's go from the left. I'm glad this came up. People sometimes write these in weird orders. You always want to go in increasing domain. So that's why I've always started to the left and gone to the right. So I'm going to use this piece from -3 until +1. And let's see, it's closed at -3, it's open at -1, and I see a slope of up 2 over 1, up 2 over 1. So I know it's going to be 2x, and I got to figure out what the y-intercept is. And for this one, it's pretty easy. Just continue the slope, and that's +3. Now I see another linear function. I see a slope of 1, and I see a y-intercept of -1. So 1x minus 1. And I'm going to use that piece on, it's closed at -1. Let's erase it so I can see it. It's closed at -1 and closed at +2. And then I'm going to use that constant function, which is y equals -2. And that's going to be on 2 to 5. And that's where that function's defined. That's the domain. And yeah, f of x equals. Okay. Before I leave this page, I'm gonna point something out to you. You see number 30, and you're gonna see this again in chapter 2. Start of chapter 2 is all this linear function review. You see how the piece that I want to point you to, because the other two are pretty straightforward, because that just has the slope of down 1 over 2, right? So you can find the y-intercept easy enough. Um, this one's not going to be so nice though. What is the slope of this function? It looks like it's going up 3 over 2. So if I went backwards, down 3 over 2, I'm not sure where that y-intercept is. It might be the way I just drew it. It looks like it might be -5, and maybe it is. Um, but I don't know that for sure. So here's a way to check. I know the slope of this function is what? It certainly looks to me like it's up 3 over 2. So y uh, equals 3 over 2x plus the y-intercept, which I don't know. And then we can just pick a point that's on the point on the line. We can use one of the points they gave us at the end point, though that one's messy. It certainly looks like 3 zeros on that line. So let's just drop in the x and the y and figure out what b is. So 0 is y, 3 over 2 is the slope, times 3 plus b. Well, 3 over 2 times 3, remember, is 9 over 2. And if we subtract 9 over 2, we'll get b equals -9 over 2, or what is that, -4.5. And yeah, see, so it didn't, my sketch was off. I wouldn't have known that exactly unless I had done this algebra. Okay, so for that piece, I'd say um, positive 3 over 2x minus, I would write 9 over 2. You could write -4 over 2. And that's, of course, going to be on what? I can't see it because I've written all over it. 1 open, closed at 6. Okay, so that's I just caution you to be able to do that, okay? Last idea in this section. We got to graph these things. Now, fortunately, these are all toolkit functions of some sort. And when I have to graph a piecewise defined function, I'll make my XY graph, XY axis, and then I'll mark in the breaking point. So in this case, it breaks at 2. So 1, 2, and I'll put a dotted line down through there just to give me a visual. And then I've got the absolute value of x when x equals 2. So an absolute value function is just as the slope of positive ones and negative ones, right? So up 1 over 1, up 1 over 1, up 1 over 1. So it's going to be stop here. Now it's less than, not equal to. So I'm going to put a circle here, open circle here, and I'm going to go this way. So there's my absolute value function. Looks like a V centered at 0, or the vertex at 0. And then y equals 5 when x is equal to 2. So let's see, that was 1, that was 2, 3, 4, 5, filled in, and it's a horizontal line. Okay, easy enough. Similar thing for this one. This one, we're going to have two breaking points because it's a piecewise function. So I'm going to draw my xy axis. I'm going to mark in -2, put a dotted vertical line because that's the breaking point. I'm going to mark in 1, That's the breaking point. And then I just got to think about how these things are graphed. So it's a horizontal line, less when x is less than or equal to -3 or -2. So 1, 2, 3. So it's included. So I'm going to put a filled in dot, shade, not shade to the left, but draw to the left. That's that horizontal line. Then I see a slope of -1, a y-intercept of 1, and I do that from 1 until from -2 to 1. So here's the y-intercept, down 1, over 1. Okay, it's filled in at there. And then I'm going to go up 1, left 1, up 1, left 1. And because it's already filled in here, technically I should have a open circle there. But because the other one's already filled in, just leave it the way it is. Um, and then y equals 3 is the other piece, isn't it? So when x is greater than 1, so y, oh, so it's the same horizontal line, and it is open there, and we shade it to the, not shade it, sorry, but draw to the right. The my open math question like this is very hard to get correct. So if you're trying it and you get things wrong, you either draw it, draw it on a paper and shoot me a picture of it, and I'll adjust, or whatever. Okay, I guess this video is probably way long, so I'll be quiet and let you get the work done.